Hi, my name is Nicole Silver, and I'm doing a socially distanced TED Talk for y'all today. And my topic is going to be Journey into Opioid Addiction and the Cerebellum. The opioid crisis is a huge public health issue in America. It began with prescription opioids in the 1990s due in part to reckless pharmaceutical company marketing and overprescription. The second wave started in 2010 with increased heroin use, and the third wave is characterized by synthetic opioids, often made with fentanyl, seen in these images here. To put this into perspective, in America, opioid overdose claims 128 lives every day. The mesolimbic dopamine pathway is the main route for addiction in the brain. However, more research is being conducted that links opioid addiction to the cerebellum, which is very interesting because the cerebellum's main function is motor control. It has been linked to some executive functions, but how is not very well understood. And I'm going to highlight some very intuitive studies that investigate the prolonged effect of opioids on the structure of the cerebellum. Several studies have been conducted that establish the correlation between opioid use and the loss of gray matter in the cerebellum. These losses have been identified in the posterior hemispheres and the cerebellar vermis. In the Ewan et al. Study, they conducted MRIs of healthy and recovered heroin addicts that did not receive methadone treatment. They found that gray matter density in the cerebellum was lower in the recovered heroin addicts versus the healthy subjects. In the Lin et al. Study, they did MRIs with heroin addicts on methadone maintenance treatment and healthy subjects. They discovered a decrease in gray matter in the cerebellar vermis and the right cerebellar declive, as well as other brain structures. Furthermore, these researchers associated this with higher depression scores. Also, the reduction in gray matter in the cerebellum and the bilateral insula correlated with poor executive function tests. Overall, this study addressed the relationship between decreases in gray matter, brain structures, methadone maintenance treatment, heroin, depression, anxiety, and cognitive abilities. Further research with larger sample sizes should be conducted, and it's also worth mentioning a confounding variable, smoking, because nicotine has been found to decrease cerebellar volume. This figure is from the Lin et al. Study, and it shows MRIs with non-stationary cluster hot color maps of different brain structures. And in the D image, a decrease in gray matter volume is shown in the right cerebellar declive. In the I image, the same thing is shown in the left cerebellar vermis. One study used voxel-based morphometry of MRIs to study gray matter in the cerebellum and cocaine use. They excluded subjects with previous nicotine addiction, and they found reduced volumes of gray matter in the cerebellum. Voxel-based morphometry is a technique for statistical analysis of T1 weighted volumetric MRIs that identifies decreases or increases in the desired tissues. So in this figure from the study, you can see lower gray matter volume in the right cerebellum at the B image, indicated by the yellow color, and this color just represents a lower T value of gray matter. The C image shows a bilateral view of the cerebellum with low amounts of gray matter and white matter. The D image exhibits a bilateral axial view of the cerebellum with low values of gray and white matter. The blue color represents a lower T value of the white matter. Furthermore, another study found results of impaired white matter in opioid users. Overall, this study found an inverse correlation between continued cocaine use and gray matter volume in the cerebellum, and this is most likely due to cocaine use causing an increase in nitric oxide synthase in the cerebellum, a finding due to research concerning morphine injections in mice and studies over morphine and opioid treatment after withdrawal. This leads to greater oxidative stress, which results in neuron damage and death. Cocaine use also imposes oxidative stress on the cerebellum by causing cerebral vasoconstriction. And this study did not evaluate healthy subjects. However, it can be inferred that a loss in gray matter does not occur in healthy subjects due to the other research I mentioned. In a study conducted by Chang et al., heroin users experienced a positive correlation between sensation seeking and decreased increased amounts of gray matter in the posterior cerebellar hemispheres compared to healthy subjects. They utilized voxel-based morphometry to analyze the differences in gray matter from MRIs. Additionally, these researchers used the Zuckerman sensation-seeking scale, which essentially measures the desire of a subject to seek out intense experiences that often come with great risk. This is a known endophenotype of heroin addiction, and these results are significant because they link an important factor in addiction relapse sensation seeking to the cerebellum. Another interesting difference is reduced connectivity between the anterior cingulate cortex, which is related to emotional, decision-making, and impulse control cognitive functions, and the cerebellum in heroin users. Disruptions in connectivity between the cerebellum and the prefrontal cortex was also found in opioid users. Additionally, connectivity dysfunctions between the cerebellum and the dorsal striatal areas were discovered. The dorsal striatal area contributes to decision-making through integration of sensory, motor, cognitive, and emotional stimuli. Furthermore, comparisons between the connectivity of the limbic system and the cerebellum was tested in healthy subjects and heroin users, and the study found a negative correlation between amygdala circuitry and the cerebellum that was not found in heroin users by comparing resting state functional connectivity. The altered connectivity shows that there could be an increase in motivational behaviors in heroin users. Overall, these studies show structural differences that could impact impulse control, reward circuitry, and habitual actions in opioid users. Differences in connectivity was also compared in heroin users who had relapsed and non-relapsers who had undergone methadone maintenance treatment. They studied resting state homogeneity patterns using fMRIs and found that regional homogeneity was increased between the orbitofrontal cortex, the right caudate, and the right cerebellum in heroin relapsers, while homogeneity in other structures was decreased. They concluded that the differences in homogeneity between these systems may be related to relapse, and that the right caudate could actually be used as a biomarker to predict heroin relapse. Another study had similar results, however they investigated changes in brain reactivity in heroin relapsers, non-relapsers, and healthy subjects when presented with drug cue reactivity tests. The highest significant difference between relapsers and non-relapsers was seen between the nucleus accumbens, the subcallosal cortex, and the cerebellum. They concluded that drug cues stimulate these areas, causing increased reward and craving behaviors, along with memory retrieval in heroin relapsers. So this implicates the cerebellum in heroin relapse. In conclusion, continued opioid use results in structural differences in the cerebellum. Lower gray and white matter volumes in the cerebellum indicate that motor control is negatively impacted. It also exhibits a relationship between sensation seeking and low gray matter volumes in the cerebellum and other brain structures, which gives a structural reason for an increase in sensation-seeking behavior in opioid users. Differences in connectivity between the cerebellum and other brain structures show a relationship between the cerebellum and key motivational, decision-making, and impulse behaviors. Typically, the disruptions in connections either negatively impact or increase the incidence of these behaviors. Furthermore, increased connectivity between the cerebellum and other brain structures like the nucleus accumbens and the subcallosal cortex indicate that they could be involved in relapse in opioid addicts. Thank you so much for watching. I hope this inspires more people to learn more about opioid addiction.